Alright, hello to a new section again, geometric sequence. Let's consider the sequence that we have right here, 2, 4, 8. Let's analyze this sequence. Now, if I rewrite 2, 4, 8, 16, and then let's say it continues forever, let's look at the pattern. First of all, we notice that to get to any succeeding term, we have to multiply the previous term by 2. So we just keep doing that, and sure enough, we'll get the each succeeding term. So notice that this value, this is constant value that we are multiplying the previous term to get the succeeding term, that doesn't change. We call this common ratio when it comes to geometric sequence. If you remember, for arithmetic sequence, we call that common difference. All right, so basically to get each term, so let's rewrite the 2, 4, 8, 6 in terms of the very first term. So first term will be 2, but the second term will be 2, and then you're multiplying it by the first term. Okay, then next term will be this 2, which is the common ratio, but now you're multiplying that with this set of new value from the previous term, which would be 2 times 2. Okay, so this value right here is actually that, and the 2's are the common ratio. This is the common ratio, that's the common ratio. Yes, you can say that that's the common ratio too, but it's already part of the second term. Now we can continue doing that, and you notice what you will get. Each succeeding term is being multiplied by the number of the common ratios, but not quite the same number of terms, but one less than that, because the very first term starts on its own. So if I start with a in here as my first term, to get the second term, I have to multiply the first term by the common ratio. Let's name this common ratio R. Okay, so R is the common ratio R. So if we want to get the second term, we multiply A by R, and then we can multiply the second term again. So here is AR, but we have to multiply that by R again. So it will be AR, or let's put down R again because we have to multiply it. So here to here, we are multiplying it by the common ratio. And then from there to there, we're going to multiply it again. So we will get R, A times R, and then R again. And then you keep doing that, and you notice the pattern. You'll get pattern that is created, and it will be very obvious when we write this in a compact form. So here is the compact form of this sequence that we just created. We're just going to put them in a compact form. We want to find the general term t sub n. So if a was the first term, t1, ar was second term, ar squared third term, notice that every time you have this subscript or the term number, the ratio exponent is 1 less than what you see. So this is 3, that is 2. This is 2, that is 1. 1, the r is actually to the power of, or to the exponent of 0. So Tn is a times r to the 1 less than n, and that is the general term of any geometric sequence. for n is the term number, t sub n is the value of that specific term, and a is your first term. Okay? Okay, so here is the write-up for it right there. Make sure you copy that down. Okay, and now let's go ahead and look at an example. All right, and sometimes it's easy just to look at the pattern and you'll do it, and that's no problem. For example, in this sequence, geometric sequence, we have 5, 15, 40, 45. We know that the first term is 5. We know that the common ratio is you're multiplying everything by 3. So that is simple. You can see that. 3. And then for any specific term, you look at the term number. So in this case, we want n is 5. We want to know what T5 is. Excellent. You can do a freestyle. You can keep multiplying 45. So 45 times 3, that will get you next number. And then another that number times by 3 again, you get another number, and that would be it. Let's do it again. So you will be getting 5, 15, 45, and then you will get 135 because you're multiplying that by 3, and then you multiply that by 3, and sure enough, you will get 405. Simple as that. So here it is. T5 is 405. You can do that, no problems. But then when you come across a question like this, where you notice that T15, that may take you too long to do a freestyle. So this is the part where you have to actually use the general term formula. So let's go ahead and use that. And in this case would be T15 equals to 5, which is A. R is 3 to the power of 15 minus 1. Simple as that. And then when you go ahead and you do the math, you get 5 times 3 to the exponent 14, and then you get 4,782,969. And notice that that's a huge number, so it would have taken quite a bit of time to do that one. So, and Tn, by the way, this thing, I just put it in here. I should have not really include that, but what is Tn? That is the general form. That is your, so Tn for this specific question is 5 times 3 to the n minus 1. So this is the form, the general form of this sequence for any term n. So look at this question. We have this question, the general term is given to us. We want to write the first 5 terms of the sequence, and that means that we want to go from n equals to 1, 2, 3, 4, and 5. Okay, and in this case, you notice that the very first term is you just plug in n up here for 1, and then you do the math. So it would be 1 minus 1 is 0, so 3 times to the 0 is 3, so the first term will be 3. Next one, you put 2 up here. Okay, so remember, this n, 2, this is what you're substituting and you're doing the math for. So in this case, would be 3 times 2, and that will end up being 6. And notice that the next one, there's a good chance that will be a multiplication. So there's a multiple of 2 is happening, but let's double check. If you put 3 in there, would be 3 minus 1, it would be 2 on top, the exponent. And then in this case would be 2 to the power of 2, or exponent of 2, 4 times 3, that would be 12. So yes, we got it, and you just keep multiplying the next term by 2, and then you get the final answer. So that's 24 and then 48. Simple as that. Here's another question. We want to find the missing term in this sequence. Now in this sequence, geometric sequence, it is a geometric sequence. We are giving the first 4. That's okay. So let's go ahead, and this one, you just use common sense based on the geometric sequence. So if I want to get to the next term, I have to multiply that by r. I don't know what r is, the common ratio is, but I do know that if I multiply that middle term right here again by r, I will get 16. That means 4 times r will get us 16. That means now let's go through and solve this. 4r squared equals to 16, and then r squared equals to 4r is plus or minus 2 because you're taking the square root of both sides. Excellent. And then you go back in there and you use, if r is 2, what happens? 4 times 2, that would be 8. 8 times 2, that would be 16. 16 times 2, that would be 32. That's one possibility. The next possibility will be if you have 4 and then your r, so this is when r is positive 2, but what happens if r is negative 2? All right, so that would be minus 8. Minus 8 times minus 2 is 16, and then minus 16. 16 times minus 2 is negative 32. Two possible possibilities for this geometric sequence, but here it is.